Good morning, students. Today we are here for studying the computer programming and utilization subject, and we are going to discuss the structure and union. The basic topics we are going to consider are introduction to structures, then how the structure variables are declared, how the structure variables can be accessed, how we can use array of structures, and how we can use arrays within the structure, as well as the nesting of structure will also be covered. So let us have a look. Let us have the look of introduction to structure. What is structure? So basically the structure was used to define the basic elements whichever are needed to define particular record. So let us have an introduction of array. Now what is array? Array are the group of items which have the same type. Means suppose I am saying that there are students, so we are considering student 1, student 2, student 3, so they are all in the one category, that is student, but they are different as particular their individuality, so they are individual entities. So we are having a particular entity 1, entity 2, entity 3, and we are giving them a same name, and that is student. So that is an array. But array is what? Array is always required to have the similar type of data types. Suppose we are considering integer or float, so they are all having the same data type. But if we want to declare other kind of data types, say suppose one is float, one is integer, one is character, so that is not possible with the help of array, because arrays are, again as I said, they are of the same data type. But many times, as I said, it's required to group information of different data types. Suppose I am considering a student entity, so student cannot have a single data type information. Suppose I am saying roll number, name, mark, so name, mark, they are of different data types, so they cannot be accommodated with the single data type. So in such cases, in the practical real examples, we are not having the similar kind of data types everywhere. One example is there, that suppose I am considering one product. That product is suppose television or laptop, and the material used inside that particular product, I am listing that all particular materials. But those all materials are having this particular attributes. Attributes are just the characteristics of that particular entity. So material is having this particular attributes such as item, part number, then dimension, then weight and cost. Now item is having this many attributes, so they are having different attribute value as per the individual material. Say suppose I am considering a screw. The screw is having some particular number, then screw is having particular dimension, it may have some weight and some cost. So again I am considering, rather than screw, I am considering an LCD screen as a material for the laptop product. So again the part number is varying, the dimension is varying, the weight is varying, and cost itself is varying. So we cannot take a single array of these particular things. We need to have some kind of data type which can accommodate or which can pack up this all stuff into one particular entity. So that's why a structure was defined in C. Let us have a quick look about structures. Structure is a collection of one or more variables, typically of different types. See, it cannot be said that it must be of same or different data types, because in such cases there is a structure which may have all the same data types. So it's not necessary when you are saying structure it should be of different data types. It can be of same, but whenever we need to group them in one particular name, that is called structure. A collection of one or more variables, typically of different types. Typically it said that it's of different types, but it's not compulsory that it should be of different types, grouped together under a single name. So we are titling that particular stuff together with a single name, and that particular name is called a tag of a structure. And this way, if we are tagging it, it would be helpful to us for a convenient handling of that particular structure. This particular concept of structure is analogous to record in a database. If we are considering any table of database, let us take an example that we are storing student details, right? So whenever we are creating a table of student, let us have a look. Suppose we are creating a student table. So here we may take particular columns. Suppose one is of serial number, one is for roll number, one is for name, one is for his subject marks, one is for his address. So these particular things are known as table. In this particular table, if I am considering this particular first row, let us take an example, serial number 1, roll number IT 25, and the name is let us say XYZ, and we are considering its mark 45 out of 50, and the address is whatever, say suppose 14 Manan Society. So this is the address, right? So this particular whole row or record, this particular whole row is known as record, right? So whenever we are creating such a record, we are having this many attributes: serial number, roll number, name, marks and address. So whenever I want to program such a suppose I want to save these particular things in my program, so at that time what I need a structure, because see here, serial number, this roll number, name, marks and address, they are not of all same type, they are having the different type. Serial number can be of integer, roll number is again a string, name is again a string, marks is integer and address is string again. If I am considering GPA rather than marks, say suppose your CPI or SPI, in that particular case this thing will be float, right? So we are not having a fixed data type, right, because they are of different types. So if I want to consider that student in my programming language of C, I need to take structure analogous to this particular record. So this is what we are saying here. The concept is analogous to record in database. It can represent a set of attributes. Attributes is what? Again the column's name. So consider the student. Now for an example, we are considering the student. So for student, this particular entities are there. One is student name, then roll number, then GPA. Again student name can be of character array, then roll number can be of integer, then GPA is float data typed value. So these three things are different, and that's why we are taking this particular stuff together into structure. So thus a structure is a user defined data type. Why we are saying user defined data type? Because it's not a primitive data type, it's not even a derived data type. Derived data types are such as, if we are considering array, if we are considering string is again derived from the character array, right? So array, and they are the user derived data type. But here we are talking about user defined data type. Why? Because user is defining this whole stuff. User is defining that what could be my definition of a structure. It's not that I have to use student every time. I can use products detail, I can use the materials detail, I can use the inventories data. So it depends on the user's requirement. User can have different attributes for that particular structure. So as I said, a structure is a user defined data type composed of members that are each fundamental or derived data type. Inside this structure there are fundamental as well as derived data types. A single structure variable would store a data for one object. Suppose I am creating a structure for one particular student, so that will store details for only one student, and that one student would be S1 or S2 or S3 or any variable, right? But if I want to consider the details for the whole class could be of 50 students. So in that case, for the same details, say suppose the serial number, roll number, name, marks, address, they all will be for all 50 students, right? So in that case, in database I would be having 50 such records. The same way in my program I would need such 50 records or 50 objects of that particular object. So in that case I would be creating array of the structure. How we are going to create this array, that we will learn later on, right? Okay, let us have a quick look on structure's definition, means how the structure could be defined in your program. So this is the particular syntax and the format to declare the structure. So we are writing the keyword struct. Struct is the keyword. Whenever we are writing struct, then only the structure is created. So this is the keyword which we need to write compulsorily. Then struct name. Whatever name we need to give to the structure, that we need to write here. So we are writing struct structure name. That structure's name is again an optional entity. How we are going to write it, that we will learn with the progress, right? But that particular structure name is optional. Then type 1, then identifier 1, means this particular type 1, type 2 are the different kind of data types. Here I am not writing type 1, type 1, type 1, type 1. Why? Because that may vary. Type 1, type 2 means first would be integer, then second could be of different type, integer and float, or integer and character, or any variations. Then type 1, then identifier 1. Identifier is again a name of variable. Suppose I am creating roll number, then roll number is a particular variable which is related to particular structure, and that structure could be of student. So we are writing struct, then structure's name or structure's tag, then type, and type, after the type we are writing the identifier. Identifier is the name of the variable. So then after we are starting with the second member declaration. These particular things are known as members of this particular structure. This type 1, ID 1, type 2, ID 2. So the ID 1 and ID 2 are the members, the member variables of this particular structure. So that could be different, and then after we are creating the variable of this particular structure. This particular variable 1 is not a variable of this particular subjects inside area. This particular ID1 and ID2 are the member variables of this particular structure, whereas this particular variable 1 is the variable of structure name, right? So that is variable of structure. Again, it's an optional. If you don't want to declare that particular variable over here, you can declare it later on. So struct, as I introduced, struct is the definition of the structure, means after struct it is introducing the definition of the structure. There the definition is getting started. Then structure name. Structure name is what? Here in this case, structure name is the entity which is defining this particular structure's name. That is also said as tag. Structure name is the structure name and is used to declare the variables of structure. Also known as tag of the class. As I said previously, it is optional, means you can avoid it if you want to. We will learn the examples of this. Then after this particular bracket, whatever we are writing, that are the structure variables, right? So after this we can list out the variables. List out means we can have more than one variable. Here I am having only one variable. I can write variable 2, variable 3 by comma separating. So if we are wanting to create the more of the variables, I can write variable 1, comma variable 2, comma variable 3, right? So variable 1 is the variable of which structure, that is structure underscore name. So whatever name we are writing there, that variable 1 would be of type structure name, right? So let us have the examples which will get us to an idea of what is structure. So we are writing struct. Again, as I said, struct is the keyword which is introducing the structure's definition, means after that the definition is getting started. So struct point. So point is the structure's tag. Then we are starting the bracket. Bracket is to define the scope of the structure. Then integer x. So we are defining first member variable, and that variable is x, and which is of type integer. Now as I said, point, I need a point in the two-dimensional space. So let us take two-dimensional space with x and y coordinates, right? Now suppose I want particular point to be drawn over here. So what I would be needing? I would be needing its x and y coordinates. So suppose this x and y coordinates are 2 and 2. Right. So in that case, I want that this particular point P1 should be having its x coordinate as 2 and its y coordinate again to be 2. So in this particular case, I need P1 to be represented as two variables x and y. P1 cannot be said as only P1. P1 should be having x and y coordinates with it, right? So we are writing x and y coordinates, and that x and y coordinates are having value 2 and 2. So again they are of the same type, integer, and the next one is also integer, but it's not compulsory that we will always be having the same data type. We can also have the different data types. So I am creating structure for this particular thing. I am writing struct point integer x, integer y. So these particular things x and y are now the members of structure. And which structure? The structure is point. So we are writing struct point integer x, integer y. You can also write it integer x comma y. It's again one on the same thing. Members of this particular structure point. Point structure के लिए x and y are the member variables. Then I am creating objects. Objects are the entities of this particular point class. So this particular point class, then I am writing struct point p1 comma p2. This way I am declaring my variables. So I am writing struct point p1 comma p2. So I am declaring 2 points somewhere in the x and y coordinate system. So the p1 could be of some height 2 by 2 and p2 could be, say, suppose 3 comma 5. So the values of p2's x and y are different, right? So we are taking 2 particular points p1 and p2. For them I need x and y. So here struct point p1 and p2 will declare 2 objects or 2 structure variables of which type? Point type. So p1 and p2 are the both point containing x and y value, right? There is the second variation of declaring the structure variables. In this case, we are in the same sentence we are writing struct integer x comma y, then bracket is over, and we are in the same sentence I am writing p1 comma p2. Look the difference here. The structure is getting completed here. Here we are not having any object till now. Then after in main method or somewhere in the same scope you are writing struct point p1 comma p2, right? But here what we are doing with the definitions continuation, we are writing p1 comma p2 semicolon. So this is the same line, same statement, right? So p